All right. I will begin with a word of prayer. So, dearly Father, we thank you. Thank you for this class. Just thank you for this time we have just to meet and study your creation. Help us to glorify you what we do, and just help the students to be encouraged and just to do their best, Lord, each day. In your name I pray, Lord Jesus. Amen. All right. So yeah, let's look at the solution to test 2 here for a minute or two. Find my laser. So yeah, it actually was A, B, C, D. I forgot to scramble them. Sorry about that. Did some of you second guess yourself and change answers because of this? Yeah, sorry about that. Didn't even notice it was A, B, C, D. So the logic here, let's just go through it. When we factor x squared minus 4, we get x plus 2 times x minus 2, but when you square it, you got an x plus 2 squared and an x minus 2 squared, which means that you're probably going to get like 2 volcanoes. That's this one. This one has a horizontal asymptote of the ratio of the leading coefficients being 4/2, also known as 2. The only one with a horizontal asymptote of 2 in all these is that. This is obviously not a rational function. That's got to be this one, because it's like a square root, and this is the only square root in this bunch, so it's got to be that one. This one here, if you factor x times x minus 3, you've got a vertical asymptote at 0, vertical asymptote at 3, so it's got to be this one. So that's how I would think about it. Now, problem 2, we make a common denominator of x minus 1 times x. If you like, you can think of it as cross-multiplying x times this and x minus 1 times that. Notice that there's parentheses we have to mind. We have to distribute the minus through. That gives us 2x minus x, which is x, and plus 1. And then down here, I have to, well, if I factor x squared minus 4, as I think you guys can do, x plus 2 times x minus 2, and then when I multiply that through, I get this and that. But notice that the x minus 2 cancels there, and the x plus 2 cancels there, and lo and behold, x plus 2 minus parentheses are your friend, x minus 2, so the x's be canceling, and you got 2 minus a minus 2, which is 2 plus 2, which is still 4. Don't let anybody tell you otherwise. There's that one. Problem 3, we've got critical numbers minus 3, 0, and 8. 0 and 8 must be excluded from the solution set because they give you division by 0. Minus 3 is fine, that just gives us 0. And so I plug in some points, I get plus, minus from the sign flip theorem. And then I'm looking for where it's negative, so that puts me over here or over there, which gives me minus infinity to minus 3, unioned 0 to 8. Again, I exclude 0 and 8 because that would give me division by 0, and I include minus 3 because that would give me 0, which I want as a possibility here. You guys have any questions, just jump in, all right? So the final exam is comprehensive, right? So what's that mean? It has everything, right? So it has a little bit of test 1, it's got a little bit of test 2, it's got a little bit of test 3, it's got all the above. Problem 4 is not entirely correct. My solution, there is a sin of omission in my solution. And the deal is this, if I forgot about this, but when I take a half power, like you guys know, if you take the square root of both sides, you got to go plus minus, right? Also true for the 3/2 power. Technically speaking, I should have a plus minus here. And if you put a plus minus here, it puts a plus minus there, it puts a plus minus there, it puts a plus minus 8. So you get x equals minus 1 plus or minus 8, which gives you either 9 or minus 8 plus 1 minus 7. And you can check it out. Minus 7 works for this as well. Because the cube root of, minus 8 is minus 2, and minus 7 minus 1 is minus 8. Minus 8 over minus 2 is also equal to 4. Now, a couple people got this, and anybody who got the second solution, I gave some bonus points to. Because it was something that was missing in my solution, so I figured I owe you something. And also, that probably means that the mission problem, remember we had a mission problem which is like x over the cube root of x equals to pi? I just have one solution for that. That means I'm missing a solution there as well. but it's kind of less obvious in that context. Or maybe there's another solution there as well. There should be two, as it turns out. Now problem 5, let's walk through it here. So we've got cube root upstairs, a square root downstairs. So cube root of a product is the product of the cube roots. I've got a cube root of 27, a cube root of x, y to the 9th power, square root of 25, square root of x to the 4th, square root of y squared. So that gives me, the cube root of 27 is 3, the square root of 25 is 5. This gives me xy to the 9/3, and x to the 4 over 2, y to the 2 over 2, which just gives me x cubed, y cubed over x squared y. Simplifying it, finally, we have 3/5 x to the 1, 3 minus 2 is 1, and 3 minus 1 is 2. So that makes a equals to 3/5. C equals to 3/5, a equals to 1, b equals to 2. So, yep. Anyway, a lot of people got this wrong. It's just going to happen. But see if you can fix it. It probably will come back for the final, so maybe you'll get it that time, right? Here, we factor x squared plus 6x plus 5. That gives me an x plus 1 times x plus 5, and then downstairs, x plus 1 times x minus 1. Notice that there's a common x plus 1. That tells me there is a hole in the graph at minus 1. And my reduced function is everything that's left over, x plus 5 over x minus 1. So when I plug minus 1 into the reduced function, I get minus 1 plus 5 over minus 1, which is also known as 4 over minus 2, which gives me minus 2. So my hole in the graph is at minus 2, minus 1, minus 2 rather. The vertical asymptote's at 1 because we have a division by 0 when x equals to 1. The x-intercept is at minus 5 because when you plug minus 5 in, you get 0. That's when it crosses the x-axis. The horizontal asymptote is the ratio of the leading coefficients, which in this case is 1 and 1. Or if you like up here, 1 and 1. So the horizontal asymptote's also 1. But a lot of people got a lot of things right here. Some didn't. This problem just, it goes, you guys find a way to get this wrong. It's like a law of this class. So yeah, here's how it goes. F plus g of minus 1 is f of minus 1 plus g of minus 1. Now f of minus 1 is what? Well, look at the graph. F of minus 1 is 0. G of minus 1, well, I got the formula, so minus 1 plus 2 is 1. 0 plus 1, 1. Okay, so f composed with g of 0 was f of g of 0. Well, what's g of 0? Well, look up here, the graph, the formula rather, g of 0 is 2. What is f of 2? Well, I look at the graph. F of 2 is 2. So the answer 2. Part C, g composed with f of 0. G of f of 0 is, well, what's f of 0? F of 0 is 1. See there? F of 0 is 1. So g of f of 0 is g of 1. What's g of 1? Well, g of 1 is 1 plus 2, which is 3. So the answers were 1, 2, and 3. And somebody asked me in the last section, was that intentional? No, that's an accident. Cool, huh? Like I hadn't planned it to be that. It just happened. I love it when that kind of thing happens. Anyway, the problems I assigned were not accidental. I intentionally made them have the structure that they did, but the fact that the answers worked out like they did was not something I had planned on. Anyway, so f of 0, we're in the case 0 is less than 2, so we use that formula, which gives us the absolute value of minus 3, which is 3, guys. Some of you left the absolute value of minus 3 like you didn't know what to do with it. Come on. We can simplify absolute value of minus 3. It's 3. This does not require a lot of mental effort, right? You guys are worried about what the bars mean? Ah, that's what I thought maybe. And so that's a safe halfway house of not simplifying is, okay, fine. But absolute value just keeps the magnitude of the number, right? How far it is from 0. Minus 3 is 3 units from 0. F of 2, that puts us in this case because equals 2 is part of this case. And so I've got 2 cubed minus 1, which is 8 minus 1, which is 7. All right, next up, the graphing problem. zoom out a bit. Now, this one here, first order of business, factor the denominator, x plus 4 times x minus 4. That reveals, notice that there's no cancellation. Nothing common to cancel. Therefore, no hole in the graph. All right, no hole in the graph for this one. There doesn't have to be a hole in the graph. There is sometimes not. This one doesn't have one. It does have two vertical asymptotes though, one at minus 4 and one at 4. And what else? It's got an x-intercept at 0 because of that x squared. Also, because it's an x squared, it's going to bounce. Right? Bounces there. The ratio of the leading coefficients is 2/1. That tells me a horizontal asymptote's 2. Like here, horizontal asymptote of 2. And let's see what else. Then I make my sign chart. My critical numbers are 0 and minus 4 and 4. It's pluses on the left and the rightmost regions. And then because you had a sign flip at 4 and minus 4, you flip to minus, flip to minus. And of course at 0, we don't have a flip. We don't flip because it's multiplicity 2, so we stay minuses. And then you graph. And the graph has to look something kind of, sort of like this. And a lot of you had some part of this right. There's only a few people who really had it like completely wrong. There's a lot of people who had something like this, but then somehow you got this to go like that, and this one down here. I mean, there's a lot of different, well, there's much diversity in the wrong answers for this question. But since diversity is our strength, you have made the class stronger. It's good, right? No? No? Okay. So here, x greater than 3 is what you want because you need a positive input to the square root. Because otherwise, you'd either have division by 0 if it's 0, or you'd have a square root of a negative number, which is imaginary. And while I love those, we try to avoid those in here for the most part. So I need x greater than 3, which gives you 3 to infinity. Some problems, I will take off points if you don't show work. This is not one of them. Like this problem 7, I think it's plausible that you could see the answer without writing work down. Other ones, if you don't write down work, and you just write the answer, I'm going to take points off because I need to see how it happened. Like I said at the start of the test, you know, show work for full credit. I mean that. If I wasn't going to give you partial credit, then there'd be multiple choice and there wouldn't be partial credit. That's a different thing. But as long as there is partial credit, then you have to show work. That's just the way it goes. Unless I find it plausible that you could guess the answer, in which case I'll bend. There are problems where guessing the answer is possible. But this is not one of them. So, right? For example, can you guess this? No. You have to show the details here. And so I think most everybody gets the 8x cubed right. We're all good on that. Like, yep, got that. Check. And then things go haywire. Usually about right here-ish. I haven't figured out exactly the location of your error. I just know that there is one because of the endpoint. Probably, if you had to go back and sort of do an autopsy on the problem, I bet what you'd find is that you did something silly like subtract the x squared term from an x or vice versa. It's probably like subtracting or adding unlike terms that got you. Hopefully my solution's right. You can check. Well, if my solution is wrong, there's at least like 10 people in the class who got the same wrong solution. That may be too much. There's at least like 5 people in the class who got the same wrong solution. And when I say class, I mean both sections. It's fairly rare for a person to actually make it to the end correctly. I probably should double check my answer, huh? You want me to double check it? No, if it's wrong, I don't want to know. I don't know. If you were convinced you're right, you can double check it if you want. But there's a lot of opportunities for weird mistakes like this. You know, minus 25 minus 48, that's 60 plus 13, that's 73. And you got 3 minus a minus 72 gives you 75. You know, and so I think sometimes people have done is like they subtract the x squared from the x in the last step or something like that. But anyway, that's the answer. There it is. naturally, guys, if you think I'm wrong about a problem, come tell me about it. I'm not offended. If I'm wrong, and I'd like to know about it. And if you feel like I've missed something in my grading, well, let me know about that too. I don't mind. I'm still upset about not getting given points back on a test that I took 30 years ago, practically, you know. I still remember. This is right. I said, this right here is right, right? He's like, yeah. I was like, well, why did you take off 3 points? He's like, it's just 3 points. I was like, but I'm right, right? Oh yeah, you're right. Can I have my points back? It's just 3 points. It's like, ah! So I try not to do that to students, although it would be hilarious. That would make today's student, like, your mind would blow. Your mind would be blown if I did that, wouldn't it? But anyway, physics was always graded on a curve, so you never really know what you had until the end. You just don't know. Like on paper, I'd have like a 65 in the course, but I'd have an A at the end, you know, because it's graded. It's not graded absolutely. Okay, anyway, this one here is a little bit tricky. What I did was I multiplied the x squared plus 4 and the x plus 3 to get me a factor which is a cubic. That way I can divide this in all at once and immediately get x minus 2 as like the cofactor, which, you know, f of x is x minus 2 times all that jazz. But that I can unmultiply back, I mean factor it to x plus 3 times x squared plus 4. That to me is the easiest way to do this. Now, if you didn't think to do it like I did it here, you could also just divide by x squared plus 4, right? And that would have given you a quadratic, which you would have known that x plus 3 is a factor of. So even if you didn't think to multiply the factors, you still could have like divided by just x squared plus 4. That still should have worked if you did your division carefully. So just saying there's other ways to do this problem besides the way I did it, okay? My pastor is currently named Zach, if you're wondering. Pastor Chuck left. I had to change the problem. Nobody reads the practice test or whatever. There was a practice test?
There was a practice test?
I thought there was a practice test.
There was. I didn't see a practice test. Where y'all find this stuff? I need to use it.
I carefully hid it in Canvas. I think it was an announcement in Canvas.
Oh, that makes sense. Canvas does that weird thing.
Yeah.
Brings all the announcements down.
Oh.
All the way at the top. You don't click on it, it doesn't show it all. I'll click on the next one.
You guys should start like a group chat or something, you know? So that, like, you know, there's strength in numbers. If at least one of you has a Canvas that works and notices that I posted, like, you know, an old test or something, then spread the wealth, you know? Because all I can do is post things in Canvas and hope that it works. And it doesn't always. It used to be in the Blackboard I could just hit email students and like it would email the students, and like people still didn't get things because people ignore their email. Fine, I get it. But now you guys can turn off email announcements for Canvas, which means that I'm just talking to myself sometimes, you know. Which isn't the worst problem in here, because I do see you guys face to face, right? But on the online, whoa, you just, anyway. So here we go, moving on. X plus 6 squared is from that bounce, x plus minus 4 squared from that bounce, and x plus 2 because x plus 2 because we had a crossing at minus 2. And then we've got f of 0 is 64, so we get that. A times 36 times 2 times 16 from plugging in 0 there. And that simplifies to give you 1/18. There it is. This one, isolate the radical, square it. Don't forget to FOIL that out. When you do, you get back down to this lovely quadratic, which factors nicely. And it gives you a solution of either 2 or 9, but 9 is extraneous. If you go back and plug it in, it don't work. Because, well, 9 plus 7 is 16, and square root of 16 is 4. 5 minus 9 is negative 4. Those are not equal. So 9 is extraneous. On the other hand, 2, it's all good. And then here's problem 12, the hardest problem on the test. You want to move the fraction to the other side. make a common denominator, bring things together, factor the numerator, and when you complete the square, you get something a little bit ugly, but not unmanageable. And then you got 1, 2, 3, 4 critical points. Draw your number line, plug in points. We've got, plus if we go over here, and then each one of them is linear, so it flips each time. Plus to minus, minus to plus to minus, minus to plus. And if I'm looking for less than or equal to 0, I either need this region or that region. I must exclude the minus 4 and the 1, because that would give me division 0, and I include the 2 plus or minus root 6, because that gives me 0 in the numerator. And there you go, that's the answer, which some people found, but not everybody. But anyway, any questions? Yes, no? I hope if you didn't do well, you see that it's not a lost cause. Like if you have these kind of questions again, you can adjust what you did wrong and get it right next time, right? I hope it's not totally mysterious at this point. We all have, we live in a fallen world. We can't do perfect arithmetic. There's always an arithmetic cost, right? Like you will make arithmetic mistakes. I will make arithmetic mistakes. We can't avoid it. But setting that aside, we can improve, right? If we get better on our concepts. And if you have a lot of arithmetic mistakes, the other thing to do is to check your work, right? Try to find strategies to check your work in as much as is possible. Now, some things just don't really yield themselves to any kind of checking process, right? But some things do, and so look for that. All right, well, let us go on here. So what were we doing? We were looking at inverse functions, right? So how are we going to calculate the formula for an inverse function? Let's do that for a nice example here. Let's work one out. And we'll do a little bit more than that. I'm going to ask some questions about domain and range while we're at it. All right? So, because there's a neat kind of sneaky thing we can do to figure out range from looking at the formula for the inverse. So I want to show you that. So example 1, let's let f of x be equal to, let's say x, 3x plus 7 divided by 2x minus 6. You can give me a 1. That's too easy. Make it a 6. It doesn't really matter. So my questions are the following. Well, they're not really questions. They're more commands. Find the formula for f inverse of y, and also determine the domain and range of both f and f inverse. Okay, so find formula for f inverse of y, and find the domain of f, the domain of f inverse, the range of f, and the range of f inverse. That's what we're trying to do at the moment. So let's get, what do you guys want to do to start? One of those questions we can answer immediately. What is it? Actually, 2 questions we can answer without any further calculation. I'll start you out. The domain of f is x such that x is not equal to, what's trouble here? 3, right? 3 is trouble. 2x minus 6 is equal to 0 when x is equal to 3. That's what we don't want. So in interval notation, because I know you guys would be disappointed in me if I did not write this in interval notation. So there it is. That is the domain of f in interval notation. What's the range of the inverse function? Remember how it goes? The function goes from its domain to its range, and the inverse function goes from the range of the function back to the domain of the function. So this is equal to the range of the inverse function. So we get that much without so much as a calculation, just common sense basically. Aw, man, that's just sad. Thank you. Man, come on. All right, how do we find the formula for f inverse of y? What's our algorithm? We start by writing y equals to 3x plus 7 over 2x minus 6. All right? Now what? Solve for x is our next move. We want to solve for x. How do you do that? Do what? Multiply? Okay, so 2x minus 6 times y is equal to 3x plus 7. Distribute that out, right? That's 2xy minus 6y is equal to 3x plus 7. We want to isolate x in order to solve for it, right? So notice that there's two terms with x. You got this one, and you got that one, right? So we want to bring all of those on one side, and everything without x to the other. So that's my next move. If I can find my marker. So we get 2x y minus 3x is equal to 6y plus 7. Right? I've isolated all the terms with x on one side and all the terms without x on the other. Once you do this, factor x out. We can do that. See, this is x times 2y minus 3. All right? Factor out the x. And finally, finishing move here, divide by the coefficient of x. We've got x is equal to 6y plus 7 divided by 2y minus 3. So this tells me that f inverse of y is equal to 6y plus 7 divided by 2y minus 3. There's the formula for the inverse function. Make sense? Yes, no, maybe so? So we've answered part of the question. What do we still need to do? We need to figure out what is the domain of the inverse function, right? And what's the range of the original function. The good news is that those are the same set, right? The domain, well, the range of the function is equal to the domain of the inverse function, essentially by definition. But what is the domain of the inverse function? Can you figure it out? You got a formula. When does that formula make sense? I'll write it this way. Y such that y is not equal to what? One troublemaker there. What is it? What's that? I heard a 3/2. I'll take it. That's the trouble. 3/2 makes that denominator 0, right? If we set 2y minus 3 equal to 0, that has solution 3/2, right? Okay, so in interval notation, then what we're looking at is minus infinity to 3/2 unioned with 3/2 to infinity. All right, there you go. So that is both the range of the function and the domain of the inverse function. I would point out to you guys, that's kind of neat, because how did we find range before? What did we have to do? We had to graph the function, right? But I didn't graph anything. And yet I know what the range is, because I know it's the domain of the inverse. Can you guys tell me what's the significance of 3/2 to this function?
If you multiply it by 2, you get 3 minus 3, which means you're divided by 0.
It's an asymptote.
It's an asymptote? Yeah. Yeah, that's right. That's right. So 3/2 is exactly what? Y equals to 3/2 is the horizontal asymptote of the function. That's why 3/2 isn't in the range. So this is not surprising for this function, but anyway. Here's another example. This time I'm going to give you guys, let's say, let's say we start at -1, -4. We go up to this point of like 0, 1. And then we go over here to this point. Let me see. All right, I got to use my measurement device here. 4. I'll put it up here. See if I can do better than I did last class. All right, so here's 3 points on a function. I'm going to connect the dots here, all right? So question number 1 is this a one-to-one function? What do you guys think? It is a one-to-one function because it passes the horizontal line test, right? So what does that mean? Well, that means that I can meaningfully ask, and so this is the problem statement. This is what you're given on the test, let's say. Then here's the question. Graph the inverse function. Okay, graph the inverse function is the problem. Graph y equals f inverse of x given y equals f of x above. So my y equals f of x is in blue. Now I want to graph the inverse. How should I do that? Yeah. Flip, yeah, exactly. We take the points and we flip them because we have the theorem that, remember, if a comma b is in the graph of f, then b comma a is in the graph of f inverse. In other words, let me just work it out for one point. If we know that f of -1 is equal to -4, then that means that f inverse of f of -1 is equal to f inverse of -4, which is to say that -1 is equal to f inverse of 4, right? In other words, that means that the point 4 comma -1, I lost my minus. That means that the point -4 comma -1 is on the graph. So -4, it's about right here. Right, there it is. If I did it right. Maybe that feels wrong. I can't do math. -4 is over here, isn't it? I'm a dummy. Right? -4 is over here. So it should be here. If I could graph, that would be good. So this point, -4, -1, right? Not over here. No. Did I do that right? I didn't do that quite right yet either. I should be the same kind of, it's more like here. All right, fine. So that's 1 point on the inverse function. How about else? 0, 1 flips to what? 1, 0. And what else do we got? 4, 8 instead of 8, 4. So out here. Now on the test, of course, I do give you guys like graph paper for this problem for sure. Like I print out a graph so that you can solve this problem using, like a straight edge or whatever. But then connect the dots, and there you have it. There's the graph of the inverse, like that. And if I did this right, if I did it carefully, the graph should be symmetric about the line y equals x. Like you should see that the graph of the function and the graph of the inverse are reflections about one another along this line y equals x. This went, I cannot tell you how much better this went this section than the last section. Like I tried to do an example like this in the last section, and it's all like curvy and wrong, and this is, one of the best ones of these examples that I've ever done. I'm very proud of this at the moment. I'm going to just enjoy it for a second. That feels right. Now, okay, so now you're making me feel silly. It's okay, I am silly. Any questions? It's almost like don't get this problem wrong on the next test. This is not a hard problem at all. All you do is pick the points and you flip them and graph them. That's all you got to do. You just take the points you're given and like turn them over. But let's appreciate this a little bit more. What's the range? What's the domain of f? What's the range of f? Can you tell me? The f is the blue one, right? So what's the domain? It goes from where? From -1, right? To where? To 8 included, right? What's the range? -4 all the way up to 4. Now, how about the inverse function? What's the range of the inverse function? It goes from what? -1 all the way up to 8. So that's the range of the inverse function. And this is the domain of the inverse function. So there's always this juxtaposition of domain and range for a function and its inverse. Another kind of problem I should talk to you guys about, lest I forget, is if you're given two functions, are they inverses? So let's just make some up, all right? So how about this? We've got f of x equals minus the square root of, let's say, x minus 4, and g of x equals to x squared plus, I don't know, 4. Are these inverse functions? What do I mean, are they inverse functions? What I mean is, when we compose f and g, do they undo each other? Let's try it out. Let's see what happens. Like, what is f composed with g? So here's my question. Is g equals to f inverse? And that question may involve a little bit. Well, let's just try. Let's see what happens. So f composed of g is f of what? F of x squared plus 4. And so what do we get? We get minus the square root of x squared plus 4 minus 4, which is what? Minus the square root of x squared. So what's that? I heard negative x, but what we should say is minus the absolute value of x, actually, is what you have here. Because the square root of x squared is the absolute value of x. All right. What's g composed with? So listen, this would be equal to x if what? If x is less than 0. So I didn't tell you if x was less than 0 or if x was greater than 0 for the formula, right? So that's an option we could explore here in principle. And if x is less than 0, then guess what? We're good, right? That works. That's half of what we need. What was the other half? We also need g composed with f of x is equal to what? G of f of x, which in this case is g of minus the square root of x minus 4. which is minus the square root of x minus 4 quantity squared plus 4, which is incidentally x minus 4 plus 4, which is x. Aha! Now, to be fussy, we're supposed to check this. We're supposed to check it for x in the domain of G. And this we're supposed to check for x in the domain of F. All right? What is the domain of F here? I mean, the formula kind of forces something on us, right? So notice that the domain of F is like 4 to infinity. All right. What's the domain of G? Well, I didn't tell you, right? So this question, as it's stated, is a little bit ambiguous, right? If the domain of G, if I told you that the domain of G was like all real numbers, then the answer is no, it's not the inverse if the domain of G is all real numbers, right? Because then I wouldn't be able to get that F composed with G is just x again. I get plus or minus x depending on the sign of x. However, so the answer to this question is yes, G is equal to F inverse provided we choose the domain of G equal to minus infinity to 0. And why do I want that? Why do I need to choose the domain of G to be minus infinity to 0? What's the relation between the range and the domain? Otherwise the algebra doesn't work, but also this, right? Like this formula right here. Think about it. What's the range? Can you see it from the formula? If you think about plugging numbers into this, it's 0, and then if you plug in big numbers, it's like minus a big number. Or you could graph it if you want. It's an upside down square root, so it keeps going down and down and down. Like the range, this is the range of F, okay? So once you understand that that's the range, you see that the G of x has to have this as its domain, otherwise it's not going to work. Yes?
Why is 0 included?
I'm sorry?
Why is 0 included?
Oh, because 0 is in the range. Because we plug in 4. Square root of 0 is 0. Let's graph this. Let's graph this. Let's graph it. Let's understand what's going on here, graphically speaking. So what's the graph of f of x? The graph of f of x, it's at 4 and it's down, so it's like this. Right, this is f of x. What's the graph of f inverse? It's x squared plus 4, right? Which is a parabola that it opens up, but it has to be this half, right? We have y-intercept 0, 4. For the function, we have the x-intercept of 4, 0. And that has the symmetry that you want, right? It's symmetric about the line y equals x, like we expect. And everything's in order. So this one's a little bit tricky in the sense that the question was asked in a somewhat ambiguous way, right? To make this problem more concrete and less tricky, I would just tell you specifically the domain of G is a particular thing, either forcing you to find out that it's the wrong thing, or maybe it's the right thing if we actually make it minus infinity to 0. So next time, maybe we'll do a little bit more inverse functions, but then we're going to move on to exponentials and so forth. So thanks, guys.